So in this video I want to talk about matrix basics, addition, and matrix multiplication. So first let me define what a matrix is. It's basically a grouping of elements which create a rectangular array. So just to refresh your mind, let's do a quick example. So here we have a system of linear equations, and if we just take the coefficients corresponding to each variable and we write it in matrix form, 5, 3, 3, we have a 0 here corresponding to x1, 0, 2, -1, don't forget the negative signs, 4. So now we have the coefficient matrix. And remember, the size of this matrix basically is a 3 by 3 matrix. And this tells you the number of rows, and the second number tells you the number of columns. If you include the right-hand side of the equal sign into the matrix, you have what's called the augmented matrix. 3, 3, 0, 0, 2, -1, 8, -3, 7, 4, 12. So because you included this information here, we call this the augmented matrix. So now let's talk about matrix addition. So let's do a quick example. So if you have a matrix of the same dimensions, so this is a 2 by 2, and this is also a 2 by 2, you can add matrix A and matrix B element by element, meaning so each term here, these are all considered elements. So if you add them element by element, you would only add up the terms corresponding to its position. So A plus B would equal 5 plus 1, 4 plus 5, 1 plus 7, and 3 plus 2. And as you can see, this corresponds to the addition of the first row, first column entry, or first row, first column element. And this one corresponds to the first row, second column element, the summation of those two guys. So this will finally equal 6, 9, 8, and 5. So you can see this in the FE review handbook. I just searched matrix and it popped me up into this section here. And as you can see, the addition is outlined in this section right here. And as you can see, it's element by element. You add up the terms, you add up the elements corresponding to their respective position. So just for your reference, for matrix addition, they're commutative, meaning A plus B is equal to B plus A. So the order in which you add the element or add the matrices doesn't matter, so commutative. Matrix addition also abides by the associative law, which means that A plus B plus C is equal to A plus B plus C. So the order in which you add matrices doesn't matter. So this is the associative law. Also, you can multiply a matrix by a scalar. So if C is the scalar, C times A plus B is equal to C times A plus C times B. So basically, if you multiply a matrix by a scalar, so if you had this matrix A and you multiplied it by 2, which is a scalar, you would get 10, 6, 4, and 8. You would multiply the scalar element by element. So now let's talk about matrix multiplication. So the first thing about matrix multiplication is that you have to have certain sizes for the two matrices that you're using to multiply. So the inner dimension has to match. Meaning, so if you have a 2 by 2 matrix multiplied by a 2 by 1 matrix, this inner dimension matches. So these must match. And your resultant matrix are these outer dimensions. So this is the size. So this will produce a matrix of the size 2 by 1. So, and this has to do with how matrix multiplication is performed. So let's do an example. If you have a matrix 1, 3, 7, 4, and you multiply it by a matrix 4, 3. So let's look at the sizes here. So this is a 2 by 2, and this is a 2 by 1. So again, our inner dimensions match, and our outer dimensions will dictate a resultant size. So we're going to end up with a 2 by 1 matrix. So how this is performed is that, so we know we're going to have 2 rows with 1 column. This first element in the resultant matrix is basically going to be this row and this row. So you're going to multiply 4 and 1 and add it to 3 times 3. So this first row, let me make this a little bit bigger. This first element is going to be 4 times 1 plus 3 times 3. The second element that goes here is going to be now this computed with, well, that row, that column of elements again. So it's going to be 4 times 7 plus 4 times 3. So this is going to result to 4. So this would be 4 plus 9, which is 13. Oops, 13. And 28 plus 12, which is 40. And as you can see, it's a 2 by 1 matrix. So basically, let's do another example to help clarify what I did there. So let's say we have a matrix 3, 2, 3, 1, 4, 6, 2, 0. We're going to multiply it by 4, 1, 2, negative 3, 7, negative 5. So again, let's check our dimensions. This is a 3 row by 3 column matrix, and this is a 3 row by 2 column matrix. So we know our inner dimensions match, and our resultant matrix is going to be 3 by 2. So we know that we're going to end up with a 3 by 2 matrix. 3 by 2. Give myself a little bit more space. So basically, we have 3 rows and 2 columns. So we're gonna fill in all these spaces. So this term, this first term here, is going to be found by multiplying element by element, that row and this column, and summing up each of the multiplication. So it's going to be 4 times 3 plus 1 times 2, or 2 times 1, 2 times 1, plus 3 times 2. So it's pretty systematic, and it follows a definite pattern. The second one, the second term down here, is going to be using this row multiplied by each element in this column again, and summing them up. So it'd be 4 times 1 plus 4 times 1 plus 6 times 2. This last element is going to be this row multiplied again by this column, because we're only dealing with this first column here. So this is going to be 4 times 5 minus 1 times 2 plus 2 times 0. So now if we look at the second column, we're going to do the same process, but now we're going to be using this second column of elements multiplied with this first row for this term here. So this is going to be negative 3 times 3 plus 2 times 7 plus, or minus 3 times 5. And all these minuses are, I'm just distributing the minuses found on the elements. So this term is going to be the second column multiplied by this second row. So it's going to be negative 3 times 1 plus 4 times 7 minus 6 times 5. And the last element is going to be, again, this second column and this last row. It's going to be negative 3 times 5 minus 7 times 2 plus 5 times 0, negative 5 times 0. So this is a negative. So if we simplify all this, and I did this beforehand, we're going to get 20, 20, 18, negative 10, negative 5, and 6. So again, this is a 3 by 3 matrix multiplied by a 3 by 2 matrix, which gives us a 3 by 2. And yes, indeed, we have a 3 by 2 matrix. And this can be row reduced. So you can do this in your calculator, or you can use operations as outlined probably in your linear algebra book. And this should row reduce to 1, 0, 0, 1, 0, 0. So that is how you do matrix multiplication. And this can be found again under the Matrices section, under the mathematics heading. This is page 34, as you can see. And they do an example of this right here. So yeah, thanks for watching, and tune into the next video.